you so much, Mia. I don't know, I found a sticky note. Hey, beautiful girl.
All right, so the digestive system takes large pieces of food that we consume and breaks them into smaller molecules that can actually be absorbed and used by our body. So let's say last period at lunch you had a slice of pizza, right? You chewed up that pizza, you swallowed it. Little chunks of cheese and dough and sauce don't go into your blood, to all of your cells. It's not like a little piece of pizza goes to each cell in your body. In order to get the nutrients from that pizza to your cells, it first has to be digested. And so that happens in our digestive system. So what is that pizza, what actually does get to our cells? We're using this pizza as an example. Helen?
Like sugar that was in it, the glucose.
So yeah, the dough of the slice of pizza that you ate, dough is a starch, it's a complex carbohydrate. It will be broken down by enzymes into simple sugars, like glucose. What about the cheese? So what are like the main components of cheese?
Calcium. Milk.
It's milk, so what is that?
Dairy.
Dairy. It is a mixture of proteins, fats, and carbohydrates all together. So, like we said, the carbohydrates get broken into simple sugars. Proteins get broken down into simpler components called amino acids.
Oh, I heard of those before.
And fats can get broken down into simpler fats and glycerol and fatty acids. So those small molecules are able to diffuse from our intestine into our bloodstream, and then they can be circulated throughout our body and be delivered to our cells. Our cells use those simpler components. So where does digestion begin? Yeah, it starts in the mouth, Jake. Right. And it happens in two ways. The first is called mechanical digestion. This is the process basically of chewing up your food. Okay? Chewing up your food breaks it into smaller pieces. So see this person eating this veggie burger, and an Impossible Burger. They're gonna have the Impossible Whopper soon.
That looks like the burger from SpongeBob.
So the Impossible Burger is a new type of plant-based meat substitute, and you could get it. There's not many places you could around here. The only place you can get an Impossible Burger, I believe, is 72 next to the Odd. They have it there. It's really popular now. In fact, Burger King test marketed an Impossible Whopper. It's a non-meat-based Whopper in St. Louis, and actually their test, it did so well that they're accelerating the rollout to the rest of the country. So pretty soon, you go to Burger King and you can get an Impossible Whopper that's a plant-based burger.
And you can suffer the consequences.
So the chewing up our food breaks it into smaller pieces. That gives it a greater surface area so that the enzymes can digest it better. I don't know, have you ever heard people say, like, when you put a bite of food in your mouth, you should chew it like, I don't know, 10 times or something before you swallow it? And there is something to be said for chewing your food well, because it's easier to digest. You know, if you just take a chunk of that burger and gulp it down, it takes a little bit longer for those enzymes to get at all the parts of that food to
But it takes
break it
quicker
down.
than one of these veggie burgers.
Chemical digestion is the process that uses enzymes to break down our food into smaller components. So mechanical digestion, we're breaking it physically into smaller pieces. Chemical digestion, we're actually changing the materials and breaking into simpler components. This actually starts in our mouth as well. Saliva is not just like water. It's a mixture of water and a bunch of other materials, including an enzyme. We have around our mouth these salivary glands. And every once in a while, they spray some saliva into our mouth. And the enzyme in saliva is salivary amylase. It's an enzyme that breaks down starch. Enzymes are specific. They only work on a specific molecule. So salivary amylase breaks down starches into simpler sugars. If you take like something very starchy, like a what's that little saltine cracker? If you put it in your mouth and just don't swallow, just keep chewing it and chewing it, eventually what you'll notice is it starts to taste kind of sweet because the enzymes in saliva have broken down a lot of that starch into simpler sugars. So that begins in the mouth. So our salivary glands spray that saliva in our mouth when we're going to eat something. Sometimes maybe if you've been like reading a book or you are looking at your phone and you yawn, if you happen to yawn at the same time as your salivary glands are spraying saliva in your mouth, some of it will come out and like spray across your book or your screen or whatever. So some people can actually, some people can like control it, and they can open their mouth and spray saliva whenever they want.
I saw a Guinness World Record. A guy spit saliva like 70 feet, just like that, like squirt. Like Sammy Sprinkler?
Was it saliva or was it like mucus? What's he learning?
I don't know.
Because that's not saliva, that's actually mucus from your nose and your throat.
What is mucus? Is it like...
It's basically a viscous
fluid
fluid to help trap bacteria
that's what it did.
and
So like
contaminants.
boogers are like good for you. That's why you get more when you're sick.
Yeah, or if you ever like, if you have a cold and you go to the doctor, sometimes they'll ask is like when you blow your nose, is it sort of clearish in color or is it like greenish and yellow? Because that's an indication that your immune system is breaking down an infection, and that's why it might be greenish yellow. Well, you have to do your job.
Because he is like,
All right.
we're good.
So as we, after we chew up our food and mechanically and chemically begin digestion, and then swallow it, your esophagus is the muscular tube that leads from the back of your mouth down into your stomach. It's about 25 centimeters long or so, and it's made with these rings of muscle that actually push the food down. So when you swallow something, the food doesn't just like drop into your stomach by gravity. It's squeezed into your stomach by this process called peristalsis. Peristalsis works like the muscles at the top contract and squeeze, and then the one below it squeezes, and the one below that, and it basically like pushing toothpaste out of a tube from the bottom. It squeezes the food into your stomach. You can actually swallow food and water upside down, and the peristalsis will still put it in your stomach. And every once in a while, reverse peristalsis might take place.
Oh.
And this is why the contents of our stomach can be ejected from our mouth if those processes work the opposite direction when you vomit.
Oh, what?
And again, vomiting is a helpful adaptation. Why is it helpful?
Because if we ingest something that's like not safe to eat, we can just spit it back out.
Yeah, so it is an adaptation that when you have swallowed something that could possibly cause infection or is contaminated with something, then vomiting helps to get rid of it because it might do more damage if it stays inside us. So certain chemicals induce vomiting. If we smell things that are spoiled or smell bad or smell like feces or rotting flesh, they can cause us to gag and vomit because those are things that can carry a lot of bacteria. It can be dangerous for us to ingest. So there are, that's an adaptation our bodies have developed through evolution. When the food gets to our stomach is sort of like a hollow muscular pad that can sort of extend and contract depending on whether or not it has food in it. And it's filled with strong acids. Our stomach has high levels of hydrochloric acid, which make it a very acidic environment. And that acid helps to break down the things that we swallow. The sort of soupy mixture of food and enzymes, hydrochloric acid is called chyme. And as the food sits in the stomach longer, it gets progressively more digested. So you probably know this if you ever gotten sick soon after eating. The things that you vomit up are still maybe recognizable,
Ugh.
chunky. If it's been a while since you've eaten, it's more liquefied, and you don't know what the heck that stuff is because the hydrochloric acid in your stomach have digested it. Now, sometimes the hydrochloric acid from your stomach creeps up into your esophagus,
Wait, is that why?
and that's called heartburn.
Oh my God, great.
So heartburn has zero to do with your heart, actually. What causes heartburn, if you ever had heartburn, it's a sensation of like burning in your chest. And that's because your stomach acids, for some reason, have started moving up into your esophagus, and this strong acid damages your esophagus, irritates it, and so it burns. You can take like Tums or some medicine like that, which acts as a base, the opposite of an acid, and can neutralize it. You could also take a medicine that lowers your stomach acid level, a medicine you take every day. Like I take 2 pills every single day because I used to get heartburn very frequently. I'd have to take Tums all the time. It's actually bad for you. If you're feeling heartburn a lot and just like taking Tums to help you feel better, it's really not good because that acid can damage the lining of your esophagus, can lead to some problems later on. So if you get frequent heartburn, probably should see a doctor about controlling the acid level rather than just like covering it up with Tums.
What is that stuff called, like bile or
Bile,
or
we'll
something?
talk about it.
Well, what is that? Is
Well, we're about to talk about it right now. Because there are some other organs that are sort of considered digestive organs in a way. They're kind of accessory organs, but food doesn't actually go through them. So one of them is the liver. The liver does many jobs. One of those jobs is, I'll come back to it in a minute, I guess. So the small intestine. So from the stomach, food moves in the small intestine. It's called the small intestine because it's relatively narrow compared to the large intestine, but it's actually quite long. If you were to cut open my abdomen, stretch out, pull out my small intestine, probably stretch from one side of this room to the other. That's how long your small intestine is, but it's all wound up inside of your abdomen.
Don't give us
And
any
so the
ideas.
food travels through that relatively slowly. And along the way, this is where nutrients can be absorbed. By the time food moves through your small intestine, it's been fully digested into very simple, small components. And it can then be absorbed into your blood, so it can be distributed throughout your body. That happens through the small intestine. Most of the digestion actually takes place here. To help with that digestion, several other organs send some digestive enzymes into the small intestine. One of those is the liver. So the liver is an organ that does several things, but one of the things is it makes a substance called bile.
Let's go, boys. I knew it.
Bile is a special molecule that helps to break down fat. And so our liver makes bile, but it doesn't send it typically directly into the small intestine. It first sends it to another organ called the gallbladder. Another function of the liver is to remove toxins from the blood,
Is that?
to break down poisons. For example, alcohol
That was one of my
is
questions.
broken down by the liver. So people that have a problem with alcohol, that are alcoholic, often suffer severe liver damage after years and years of drinking because their liver is constantly being stressed by detoxifying that alcohol. So the liver makes the substance bile, so like a greenish yellow fluid that helps to break down, but it sends it first to the gallbladder to be stored. And then when the bile is needed, the gallbladder then squeezes it through the bile duct into the small intestine. Some people have problems with their gallbladder, like my wife, for example. She would get gallbladder attacks where it was very painful, so she eventually had her gallbladder removed. And you can have your gallbladder removed, it's just, then your liver sends the bile directly into your small intestine without sending it to the gallbladder first. And you know, you sometimes have to be careful of how much fat you eat in that case, because you don't have large amounts of bile being stored up to help digest it, but really it can be removed and it can be not a big deal. The pancreas, as we learned, has endocrine functions by producing insulin and glucagon, but it also has a digestive role. It produces what's called pancreatic juices that are a mixture of enzymes to help break down various foods that we eat. Sort of near the stomach, and it's shaped kind of like this L-shaped fork. So inside of the small intestine, inside the small intestine, it's not smooth like a hose. It has all of these bumps and ridges called villi. They're very important because in these villi, there are tiny capillaries. What do you think those capillaries do?
Transfer the nutrients and
Yeah, they take in those nutrients that we've digested. They go from that chyme that's moving through the small intestine, they diffuse through the wall of the intestine into the blood vessels, so they can then be distributed to different parts of the body. So this is where the nutrients are actually absorbed, through the villi of the small intestine.
Wait, so if you're like your mouth connects to your esophagus down to the small intestine, and then your small intestine goes to what, your butt?
No,
Where does it go?
large intestine.
Where is it
So,
going to that go?
The small intestine, okay, the small intestine connects to the large intestine. So the food's gone through 25 feet of small intestine. By the time it gets to the large intestine, which is wider but shorter, it's actually everything that was valuable really has been taken out, has been absorbed. And all that's left really is water and a mixture of the things that our bodies can't digest. And so when this mixture gets to the large intestine, it has to go up our right side of our body, the ascending colon, across our body, okay, the transverse colon, and down the descending colon. And as it's making its way, our large intestine absorbs excess water, hopefully, from that mixture. And eventually, by the time that mixture gets to the end of the large intestine, okay, anything of value has been sort of removed, and all you're left with is undigested material. Material we would call feces or poop. And that makes its way to the rectum, where eventually it's eliminated through the anus. Now sometimes the large intestine leaves too much water in that mixture, and what does that cause? Too much water. Diarrhea, yeah. And not enough water left in the feces
Constipation.
lead to constipation.
Oh.
Sort of opposite problems. But actually, in the large intestine, there's really no digestion happening there. All the food's been fully digested already. It's just reabsorbing water and getting rid of that undigested material.
So technically, the food you eat never comes in contact with anything outside of your digestive system. It just goes,
Technically, the food
right
you
out.
eat
It's hollow.
is never inside of your body.
Yeah, that's what.
So basically your mouth
Yeah.
all the way to the anus is not inside of yourself. It's just a tube within your body.
That's what I
So,
was trying to get at.
yeah,
When I was like saying,
Wait,
well,
what?
where is that?
Dude, it's just
The
like
food,
it's
it's
a
just,
hole
it's
through
just
you.
like a tube, so it never
So
comes
that
to the
undigested
actual
food
mouth.
never actually is in your
It's never in your
cells
mouth.
until things are absorbed that are digested. All right, let's look at this diagram. So
it goes
it,
through our
this
mouth.
doesn't show our mouth,
and out.
but the top is the esophagus, which would connect to the mouth. Connected to the stomach, which leads to the small intestine, which leads to the large intestine. That's the pathway that food travels. Mouth, esophagus, stomach, small intestine, large intestine. But along the way, these other organs help add to the digestive system and to further digestion. And those are the liver, which makes bile, the gallbladder, which stores it, and then the pancreas, which produces pancreatic juices.
What was I gonna say? What does your kidney do?
We're going to get there soon. So I'm going to hold off on your
What
question.
about the appendix?
The appendix is a part, so it's not really shown here. The appendix is a little tiny extension of the large intestine here. And the appendix, people say sometimes it has no function, but scientists believe now, so our digestive tract is teeming with bacteria, beneficial bacteria that help us to digest our foods. They're really important for us. In fact, if your bacteria, your gut bacteria are killed off, maybe because you're on a strong antibiotic, it's actually a problem. It causes you to have stomach pain, okay? Because these foods are not being properly digested. So scientists think that the appendix is like a little area for these bacteria to sort of hang out. And so if your gut bacteria are wiped out, it can be repopulated by bacteria from the appendix. You can live very easily without your appendix. I don't have one.
Yeah, my mom doesn't.
So when I was 11, I got appendicitis. I was really sick. I threw up 38 times in a single day. And so we went to the hospital. My appendix was infected. If your appendix is infected and is in danger of bursting, that could be dangerous because it can spill bacteria into your body cavity and can spread and be really bad. So if your appendix gets infected, they probably will remove it. So I had mine removed. This is what, from the bodies exhibit, shows sort of the pathway food follows, starting with the esophagus, the liver, small intestine, large intestine. I guess I'll come back to the video because it's really cool and towards the end of class. Let's just move on here and then we'll go back to it. So the next system is the excretory system. Excretion, do not. Excretion is the removal of metabolic waste from the body. Things like carbon dioxide, compounds found in urine and sweat. Those substances must be removed from the body. If they build up, they would become toxic. So our kidneys is one of the main organs that helps to do this. We have two kidneys in our body. They're near the bottom of your abdomen, towards the back of your body on either side of your spine. This is why it's illegal, like in boxing, to punch somebody in the lower back, okay? Because your kidneys are there and damage to kidneys could be dangerous. The kidney's job is to filter our blood. All the blood in our body comes into our kidneys where they extract these waste products. They mix them with water to form urine so that we can excrete them from our body, okay? So the kidneys filter our blood. They send that urine that they're producing through a tube called the ureter. The ureter is carrying a constant drip of urine from our kidneys to our urinary bladder, which stores it up. So our bladder is constantly, slowly filling with urine. Now, if you're well hydrated, if you've drinking a lot of water or fluids, your kidneys sort of can recognize this. And so they put more liquid, more of that water, into your urine. If you are not drinking a lot of water, say you're dehydrated, your kidneys adjust to maintain homeostasis, they put less water in your urine. So that's why if you're well hydrated, your urine is relatively clear because your kidneys are sending the excess water there. If you're not well hydrated, you're not exercising a lot or whatever, then your urine is darker in color because your kidneys are conserving water by putting less with your urine. So eventually, the bladder fills. Our brain can sense through neurons connected to the bladder when our bladder is filling, and that gives us a signal that we need to use the bathroom. And then when we do, the opening of the bladder opens, and the last tube that carries it is the urethra. The urethra carries that urine from the bladder out of the body. And so basically the way the kidneys work, all of the blood in our body goes to the kidneys where they can extract these waste products, mix it with water, and send it on its way as urine. Now, you can live okay. You can live just fine with one kidney. Sometimes people get kidney disease. They might have a trauma to a kidney, and one kidney might stop functioning. And the other kidney will do okay. It'll do the job, it'll filter the blood properly, and a person's fine. However, if both kidneys are damaged, both kidneys are not working, then that's a dangerous situation. A person must have at least some kidney working. And so when a person has kidney disease, they might go for dialysis. Dialysis is, have you heard of this?
Yeah.
Dialysis is when a person goes to the doctor's office, 2 or 3 times a week. They hook up to a machine that actually takes their blood out. The blood goes through this dialysis machine, and it basically acts as an artificial kidney. Filters out those waste products, and then it puts the sort of cleaned blood back into the person. It works okay, but again, you have to go constantly for dialysis. You can never stop. What's the more long-term treatment when a person has a problem with their kidneys? Ashley? Yeah, transplant. So kidneys can be transplanted pretty well, very successfully. And the good thing about kidneys is that a relative can donate, if they have 2 healthy kidneys, can donate a kidney to somebody that's in need, and then they still have a working kidney that's fine, and then the person that got the donated kidney is also then going to be fine. So kidneys can be donated. Sometimes people donate organs after they pass away, so sometimes they come from people in that situation have donated their organs. Other times they come from a living kidney donor.
How long can someone live without a kidney?
If they're going through dialysis,
No.
without dialysis, not long. I would say if they have no functioning kidneys, maybe a week. I'm kind of guessing, but I would think that's around where it is.
Not great.
All right. I guess let's finish this. Our skin and lungs are also considered excretory organs. For example, when you sweat, sweat isn't just water. It's also salts and even urea, the same stuff that's in urine. There is some urea in what we sweat out.
Is that why it sweat stinks?
Yeah, that's part of the reason why. Also, bacteria can live in that sweat. Also, you may notice the salts if you play baseball or some sport, like inside of your hat. You're constantly sweating into it, and then as the sweat evaporates, the salts are left over.
Oh, and it becomes like
Whitish, crusty.
Yeah.
That's. Or if you go out and you're running for a long way and you're sweating a lot, as the sweat evaporates, the salt stays on your skin. So sweating, the main role of sweating is not so much for eliminating waste, it's more about controlling temperature. But a secondary function is to remove some of these wastes. And our lungs are a really important excretory organ for removing carbon dioxide. As we breathe out, not only are we taking in oxygen to refresh our blood cells, we're also removing carbon dioxide that our blood has picked up from other cells of our body. All right, any questions about these systems? I'm going to show you this cool video. It's